So we got the next integral over here, and some of you may look at this and be like, okay, I can apply algebra on this. I can actually apply u sub on this. Some of you may think that, and that may be due to the reason that this thing inside the secant squared is the same as this thing right over here. But remember, that's not what u sub wants you. That's not what u sub demands. The u sub, if you make this thing right over here your u, then the differentiation needs to be present outside. But you can clearly see that 3x is going to differentiate to just 3. And what are you going to do about that x? So 3 doesn't matter. It doesn't matter if you have the 3 outside or not. But that x term does matter. And what are you going to do about that x? Because you clearly don't have an x in your differential. So you cannot apply u sub on this. And therefore, the only technique that we've learned so far is going to be by parts. Now, I'm going to, just by looking at this integral, I can tell that that is what I want my f of x to be. Why? Because when I differentiate this, I know I'm going to get rid of that x term. And once I get rid of that x term, my integral is going to be way more simpler. If I look at this secant squared 3x on the other hand, what happens if I integrate or differentiate this? So if you integrate this, I believe this becomes tan x. And if you differentiate this, I don't know what this becomes, right? I think I'll have to differentiate it in a bit. I don't really know what it becomes, but I think integrating it makes it tan x. But the idea is you don't even really need to look at this right now, because you can look at that 3x and know that, okay, if I differentiate that 3x, I'm going to get a really useful answer. So that is what I'm going to do. I'm going to be differentiating that 3x. I know differentiating that 3x is going to get rid of that x term over there. So then that leaves me with this term, and this term is what I'm going to be integrating. So I'm going to make it my g prime of x. So my f of x is going to be 3 of x, which is going to integrate to 3. And then my g prime of x is going to be secant squared 3x, and then my g of x, if I integrate secant squared 3x, when you integrate secant squared 3x dx, what you're going to do is you're going to realize this is actually not a general integral. It's not a simple or a general integral. It's a complex one, because the simpler form of this would have been secant squared x, but it's clearly not that. You have a 3x over there. So how can you remove that 3x to make it general? Well, you'll have to apply u sub on this. U sub is the only technique that is going to convert this thing into its general form. So you apply u sub on that, you make that thing right over there, you turn it into your u. And basically the answer you're going to get is, I'm not going to do that for you guys, but the answer you're going to get is going to be, I believe it's going to be tan 3x, and I believe it's going to be divided by 3. I believe that is going to be the answer. Yeah, so that is going to be your answer. And so this thing integrates to tan 3x divided by 3. Okay, so let's get on to integrating this. This is going to be f of x times g of x, as the formula says. So it's going to be f of x times g of x. It's going to be tan 3x over 3. Cancel out that 3 with this 3. And then you're going to be left with minus f prime of x, which is 3, times g of x. So that's going to be tan 3x dx over 3. So this 3 is going to cancel out with that 3, and you're going to be left with tan 3x minus integral tan 3x dx. Now you guys do already know from the previous video or the video before that you can actually go ahead and integrate tan x's. So you can integrate tan x integrals, and you can integrate cot x integrals using u sub. Using u sub. So you basically convert this into sine over cos, and you convert this into cos over sine, and then you use u sub, and that solves your problem. Well, over here you can do the same. First, what I would recommend you to do is basically turn this thing into a turn this thing into a sine 3x over cosine sine 3x over cosine 3x. And then this thing right over here, when you differentiate it, this is going to become 3, it's going to become negative 3 sine 3x. You already have this part up there, and you can, the numbers don't really matter, so you can apply u sub on this as well, and it's going to solve for you. Right, so we got our final integral over here, and this integral is a bit tricky because you realize this is the kind of integral where differentiating or integrating anything doesn't really matter anymore. So you got this thing. What happens if you integrate or differentiate e of x's? Right? I'm not talking about e3 of x, because we can get a rough idea of what's going to happen with just the simple form. So if you integrate e of x or you differentiate it, it just ends up with e to the x. So it doesn't, this thing really doesn't make that much difference. Cosine 2x doesn't make a difference either, because what happens when you integrate cosines? When you integrate cosines, they become sines, and when you differentiate them, they become negative sines, and then they keep on alternating as well. So this thing right over here, this thing really doesn't make a difference. You can go ahead, choose this as your g prime of x, or this as your g prime of x. It's your choice. What I'm going to do is I'm going to actually go ahead and choose this thing right over here as my f of x. So I'm going to be differentiating this, and this thing right over here is going to be my g prime of x. I'm going to be integrating this. You can do it the other way if you want to. So let's write my f of x over here, which is equal to e 3x, and if I integrate this, my bad, if I differentiate this, I'm going to get 3e 3x, and then this g prime of x is going to be cosine 2x. What happens if I integrate this? So when you integrate this, you are going to get negative sine, my bad, you are going to get positive sine. So you're going to get sine 2x over 2. So apply the formula, which is going to be e 3x times this g of x. So it's going to be sine 2x over 2 minus integral. It's going to be 3e 3x sine 2x over 2. Right? Carry this 3 and this 2 outside of the integral, because you can see they are constants. So you can just go ahead and write them over here. Okay, now you're left with this thing inside, and of course you're going to have your dx. So how do we solve out this now? How do we solve out this integral out? Well, you realize that you have to apply by parts on this, and again, you can either integrate this or differentiate this, or integrate this or differentiate this. It really doesn't make a difference. They're going to keep on alternating forever and ever and ever. So I'm going to consider this as my f of x, because that's what I did in the first case, although it's not necessary, but that's what I'm going to do. And I'm going to consider this as my g prime of x. So my g prime of x is equal to sine 2x. And so when I integrate that, I get negative cosine. Do I get that? I don't know. Hold on. Sine 2x dx. So this is going to be negative. So this is going to be negative cosine 2x over 2, and my f prime of x would be e to the power 3x. I know what that is. That's just going to be 3e 3x, and my f of x was e 3x. Okay, so I'm going to do by parts over here again, and so that is going to become e 3x negative cosine 2x over 2, subtract by the integral, and the integral is going to have f prime of x, which is 3e 3x, and it's going to be multiplied with g of x, so that's going to be negative cosine 2x over, this is a 3x, cosine over 2 dx. Okay, so this again is a constant right over here. I can go ahead, take that out of the integral, and so that's going to simplify to this thing. So that's going to become that negative and negative is going to cancel out, and I'm going to be left with 3 by 2 integral e 3x cosine of 2x dx. And by now you've probably realized you can go on and keep on solving this using your by parts, and it's always gonna alternate. You are never going to get a direct answer for this. And sometimes you're gonna be stuck in cases like that. So you may just go ahead and be like, okay, so that does that mean that this initial integral doesn't have a solution? Well, no, it doesn't mean that. It means it has a tricky solution. So this is my answer that I got from doing by parts on this integral. So I'm just going to pop that in. So this is going to be, if I just erase all of this, then I'm going to go ahead, drag this thing, and I'm going to pop that down there. So I'm going to pop that down there, and this is being multiplied with that negative 3 by 2. And I can actually go ahead and solve that out. So when I solve that out, I'm basically going to get e 3x sine 2x over 2 minus, and that 3 by 2 is going to multiply with that thing first, this thing first. So those negatives and negatives are going to cancel out. That's going to be 3. That 2 is going to multiply with the 2 in the denominator. That is going to be 4. That is going to be e 3x cosine 2x. And then I'm going to have negative 3 times 3 is going to be 9. 2 times 2 is going to be 4. And this is going to be e 3x cosine 2x dx. Okay. Now if you realize this thing was actually the thing that you started off with. Okay, and you can go on and do more by parts on that, but you're just gonna keep on revolving. You're just gonna keep on getting the same answer, and you're gonna be stuck in the same place. So what I want you to do is I want you to realize, if I can just quickly erase all of this, this initial thing basically gave you that answer right over there. Okay, so this is e 3x sine 2x over 2 plus 3e 3x over 4 cosine 2x minus 9 by 4 e 3x cosine 2x dx, right? And what you can see is that this thing and that thing are completely the same. So what I want you guys to do is I want you guys to imagine this thing as a, and so that thing would be a as well, right? If I just give it some algebraic variable, let's say I call this thing a, then what I can do is I can actually go ahead and take the a to the other side of the equation. And so what's going to happen if I take this a to the other side of the equation? Well, if you have an a over here and you have a minus 9 by 4a on the other side, and you take it to the other side of the equation, and what's going to happen is that you're going to get a, and you're going to get plus 9 by 4a. So this thing is basically going to become 4 over 4, and so that's going to be 9, 10, 11, 12, 13 over 4a. And so what you can do is you can actually erase this thing from over here and realize that your final answer is going to be 13 over 4, this integral. And now what you can do is you can basically get rid of this thing, and how you're going to do that is basically if you send this 13 by 4 to the other side. So this is going to be 13, that is going to be 2 e 3x sine 2x plus, so this is going to be 13 3e 3x cosine 2x, and of course don't forget your plus c. So this right here is going to be your final answer, and that this a thing that I did over here, this is exactly what you do when you start to repeat, when you're doing by parts and you start to get the same thing that you started off with. Then you basically go ahead and apply this a thing that I just did over here.